In this section we're going to look at creating a frequency chart which we'll use to create histograms later on. Now in order to do that we need to break data down into something called bins. And if we look at our vocab here, a bin is just a range of numbers that gets grouped together. So imagine that, for example, if you look at youth baseball, you might think, okay, ages 9 to 12 get binned together to play Little League. And ages 13 to 15 get binned together to play Babe Ruth, and so forth. So bins are really just ranges of numbers that get thrown together. Now one of the things that's going to be important is that our bin sizes are all exactly the same. We can't have one bin that's has 4 different ages and one bin with 3 different ages. We need to make sure every bin captures the same width. Second thing we have is a frequency chart. It's just a table, and all it does is it lists all the different bins and how many things go in each bin. So all the different bins that you have and the count or frequency of how many things are inside of that bin. And we'll practice making these in just a second. So one rule of thumb is that when you're dealing with small amounts of data, like the kind of thing that we're going to be dealing with generally, where we don't have very many numbers at once, usually 6 to 8 bins is a pretty good rule of thumb. Even things on that low end of 6 different bins that things can be broken into is usually fine when you're dealing with such a small amount of information. So going back to the earlier example, we have our distribution, and our minimum was 4, and our max was 24. Now, let's figure out how wide each bin should roughly be. It says how far apart are they? How far apart is the min and the max? They are 24 minus 4. They are 20 apart. And then we're going to take that 20 that we got and divide it by 7. And if you take 20 divided by 7, that's pretty close to 3. So when we round it off, it's going to be 3. We're not worried about exactly what it is, but 20 divided by 7 is roughly 3. Now we have to create these bins. We need to fill these bins with the different numbers from our list. So I'm going to start around 4. And just to make sure there's no confusion, I'm going to overlap the size of my bins. So don't write this down for a second. I just want to show you a problem that we might run into if we did not overlap our edges. Imagine that we have one group that says 15 to 18. And then we have another group that says 18 to 21. This is 15 to 18 here. What would we do when we came across an 18? Would it go into this group on top or this group on bottom? It kind of depends on who designs the histogram. There are some general rules, but what we're going to do is we're going to try to avoid that altogether. All we're going to say is, let's just start not at 4, but at 3.5. So if we start our first bin at 3.5, and go up 3, then it goes up to 6.5. Then we'll never have that problem of having 2 edges of the bin kind of collide into each other, and we're not sure what to do with things like that. So this just makes it work a little bit better. I'm going to fill in this table, and then you can compare it to what you have in just a second. Now let's total up the frequencies to see what numbers in our distribution belong to which of these bins. You'll notice with the bins that I would go 3 wide, just like we said for our bin width, this 3 over here, and I would keep repeating and adding 3 to each boundary. And it's set up so that all the numbers should be whole numbers, and none of them will have issues with the edges of this boundary. So let's go ahead and start making tally marks. We have an 11 that goes in between 9.5 and 12.5, so we add a tally. And then 15 fall in this first group. We have 18 and 19, and so 18 goes in this group here, less than 18.5, and 19 goes in this group. And the idea is that you keep making these tallies all the way across until you filled in this chart. When you're all done, you might end up getting tallies, something very similar to what I got. And if you would like to, you can take those tallies and summarize them into numbers. So in this case, 1, 2, 1, 3, 4, 2, 2. And what that does is that allows you, when you decide to make a histogram, it allows you to see how high each bar is going to be on that graph. By counting up the frequency of what falls into these bins, it's going to help you draw that histogram. Now, one thing to always take histograms and frequency charts with a grain of salt, because you can make very small adjustments to, let's say, how wide each bin is or where the bins start counting, and you can make your data look pretty different. So obviously the goal is not to make the data look like it's not valid for comparison, but that is one thing that you will